Hello, welcome everybody. Thank you for giving us 10 minutes there. We're just in the lobby checking everyone's microphones worked, everything like that. So yeah, welcome to our IMechE Railway Challenge Team Advice and Networking Day. We've not done one of these before, yeah, we'll see how it goes. So for those who don't know me, my name is Martin Evans, and although I'm currently based at the University of Huddersfield, I've been involved with the Railway Challenge since at least 2013 when I started the Railway Challenge team at University of Sheffield. So that's 10 years ago now. We'll be hearing more about that in their presentation later. But before that, we'll hear for some judges and last year's winners, Poznan. Many of you might know this event was originally intended to be a full-day hybrid event hosted at the University of Sheffield at our Institute of Railway Research. This would have included a tour of our facilities and a chance to meet other teams face-to-face. The idea was that this event could move between institutions each year, giving each institution a chance to host so giving each host a chance to showcase their facilities. Unfortunately, due to a lack of in-person sign-ups, we've had to reduce the scope to an online morning-only event. So we hope this is still useful. We hope to include some virtual networking at the end of the session, although we've no idea how well this will go. The event nominally finishes at 1 p.m, but you're welcome to stay online if your discussions are going strong. So towards the end of the session, I will be sending out an anonymous poll just to get feedback on how useful this event was and to gauge interest for future events. So look out for that. Well, I'll let you know when that happens towards the end. But without further ado, let me just hand over to our first presentation from Simon, an introduction to the Railway Challenge. Simon, are you ready? I can see you've unmuted.
Thank you very much, Martin. Can you hear me okay? Okay, I see people nodding. I'm going to share my screen. Hopefully that's working. Okay, can you just give me a nod, Martin, if you've got full screen?
All good, thank you.
Okay, good. Okay, so thanks very much. And yeah, as Martin said, the Railway Challenge has been running for quite a while now, but I thought it would be useful if I just give you a little bit of background and perhaps an update on what we're doing this year. There'll be more detail later. My name is Simon Dubnitsky. I was Professor of Railway Engineering at the University of Huddersfield, and before that at Manchester Metropolitan University, where I was when we started the Railway Challenge. And I'm currently the chair of the organising committee of the Railway Challenge, where we plan all the aspects of the challenge itself. A little bit about the background. So it's an annual competition. I know you most of you online, I think, know all of this, but let me just quickly run through it. Maybe some people haven't been before. It's organised by the Railway Division of the Institution of Mechanical Engineers, the IMechE. The Railway Division is very active, includes senior people from the railway industry in the UK and overseas. And we felt 12 years ago when we started it that this would be a good way of engaging young people and showing them what an attractive career there was to be had in railway engineering. So teams of engineering students studying at a university, or graduates or apprentices who've recently graduated or are active on their apprenticeship or recently completed it, working in industry. Those are the teams that are eligible to take part. And what they do is they compete to design and manufacture a miniature gauge railway locomotive. That's 10¼ inch gauge, 10¼ inch between the rails. So still a reasonable size. As you know, the locos weigh, well, upwards of half a ton in most cases. And we provide a set of rules and a technical specification. There are subcommittees of our organising committee that prepare each year the rules and the technical specification. The rules change a little bit each year. We try and make it so that a team couldn't just bring back the same locomotive and keep winning. We change things each year. It's held at the wonderful Stapleford Miniature Railway, which is near Melton Mowbray in Leicestershire, in the centre of the UK. No, probably not the centre of the UK, the centre of England anyway. And we get great support from the Friends of Stapleford Miniature Railway, who run their own railway there. It's a lovely location. It allows us to run on a reasonable length of track and camp on site as well, and have access to great facilities there, great support from them. It started in 2012, and we're now in the 13th year, although we did miss a year of physically participating due to COVID. So these are the aims. This is how we set it up when we originally agreed as a board of the railway division that we would have this challenge. So as I already mentioned, the main aim is to make young people aware of the interesting challenges facing railway engineers and the excellent career opportunities for all sorts of railway engineers. We provide a structured environment with these rules and the technical specification, which means that it's fairly risk-free. Of course, nothing's completely risk-free, particularly when you're building a sophisticated piece of equipment and running with them. But it is a representative environment. Although it's miniature gauge, it still has all the systems that are required in any kind of full-size, complicated engineering system like a railway vehicle. And that means that people can develop key engineering skills, and also, I don't mention it there, but the other kind of skills, the softer skills, procurement, team working, time management, all those sort of things. Camping on site, most teams camp on site, and we have some social events. That means that networking takes place, and many past team members keep in touch with each other, and many of them have joined the railway industry and have careers, successful careers, and even senior positions in the railway. Okay, the challenge, this is what the sort of scenario that we set up. Teams assume that they're working for a design consultancy, producing a locomotive for a large corporation. As part of it, one of the challenges is a business case presentation. That's the sort of role that you have to take. You've designed this loco, you're trying to sell it to a potential customer. And then, of course, you have to also, as a team, design and manufacture a prototype of this locomotive, and then you're tested against other teams in the various challenges. One of the key things right from the beginning was that we didn't want it too much to be sort of judges making subjective decisions. So it's very objective. In other words, you run your locomotive in the physical test, and if you're the fastest or the quietest or the most energy storage, you will win that challenge. And the other scores are factored down according to that. Rules and tech spec, they're all online. We'll come back to that in a minute, but at the bottom of the page there, you can see the web address. I'm sure will have looked there. Everything you need will be on there. So in particular, now we have the 2024 rules and technical specification. They're not massive documents. You need to make yourselves very familiar with them. I think others shortly will be talking a little bit more. There are some drawings and there are other things on that website, which I'll come back to in a second. So for 2024, this is a little summary then. The challenges change a little bit each year. You might have noticed if you've participated in previous years that there are some differences. We've dropped one or two and we've added some new ones. So this year, the track-based challenges are the auto stop challenge. This is where the locomotive has to detect a marker that the team puts down on the track at a specified location, and it has to stop a specified distance, 25 meters, after that marker without any intervention from the driver. Ride comfort challenge, the judges fit an accelerometer, a triaxial accelerometer onto the locomotive. You can specify the technical spec tells you how to set that up. We'll provide the accelerometer, we'll fit it on, you'll run around the track and we'll collect the data and weight it according to conventional standards, and the one with the best ride comfort will win. Energy storage, you have to run the loco at up to line speed, you have to cut the tractive power, and you then have to store energy as the loco comes to a standstill. Has to stop at a specified location between two markers. Once the judges give you permission, you can then move forward using only the stored energy. The loco that moves the furthest wins that challenge. Traction challenge, basically you have to accelerate from a standing start, pulling a rolling load. Loads changed this year. Upper gradient between two markers as quickly as possible. Reliability challenge. This is slightly different. We give you some points at the beginning of the challenge, and anything that your loco fails in terms of reliability. So if it doesn't appear on time for when it's booked to do a certain challenge, or if it fails in any way or needs to be rescued, or any other infringements like that, you lose points. It's all written down in the rules. You can look at how many points will be lost. You can't end up with minus points on that one. Maintainability challenge. This is one that's always good fun for spectators to watch. Teams have to remove a powered axle from the locomotive, take it away from the locomotive, and then put it back in. It's done in stages to make it safe. The one that can do that the quickest, sort of a little bit like a Formula One pit stop, but not usually quite as quick. Okay, then there's some presentation challenges. There's a design challenge where you have to prepare a document describing the vehicle, and that's assessed offline. Business case challenge. We originally did this at the event, but we've been doing it offline recently, where you make the case to the potential purchaser, as we've discussed, of your locomotive. A poster challenge where you have to prepare a poster, and that's assessed in various different ways. Some slight changes to the rules for these presentation challenges. Have a look for this year. And then an innovation challenge where you have to prepare a sort of an academic type paper describing one or I think more than one of the innovations in your locomotive. So those are the main challenges for 2024. If you have any questions, we have a Q&A session afterwards. I or any of the other judges that are here will be happy to answer those. Then new for 2024, we've introduced some optional challenges. You basically pick one or more of these and you get marked. You get marks for the one that you do best in, but you can attempt more than one if you want to. You have to indicate, we'll come back to this, but you have to indicate which ones you want to attempt, and then we will say which of these are running, because they may not all run, depending on, we need at least 2 teams, obviously, to be participating in it, to be able to score it properly. Auto coupler challenge. Your locomotive has to come towards another vehicle, automatically coupled to it. The locomotive, you drive it away, and then you automatically decouple from it. Again, there's some detailed rules written in the rules that you can look at. Aerodynamic drag challenge. This is an offline challenge where you use computational fluid dynamics tools to predict the aerodynamic drag on your locomotive. It's run at a faster speed than we would be able to on track. Then there are 2 sort of related ones. There's a location announcement challenge. This is where the locomotive has to detect its position around the track. We'll have a quick look in a minute at the locations and make suitable announcements, potentially to passengers, but to people around the locomotive on the trailing carriage, stating where it is. And then there's the remote data recording and monitoring challenge. We've specified, I think, 10 aspects of the status of the loco, its condition, and those have to be transmitted to a remote location, probably in the marquee, where spectators gather, and an announcement or a visual announcement will have to be made of that status that can be seen by spectators and judges. Okay, and finally on the challenges for this year, this isn't the first year we've done this, but we have an entry-level challenge, which is open only to teams who are entering for the first time. If they wish to, they can follow all of the rules and submit written documents, but they don't need to manufacture and bring a locomotive. If they're doing that, there's an additional CAD challenge, so a bit more detail on the CAD drawings that have to be submitted. There's a separate prize for this, and teams can enter the other non-track based challenges as well. Okay, so this is very small, but it's on the website. You can't see the details, but I'm just showing you on there that the numbered points that the loco has to detect to make the announcement and to feed the status back are shown on there. And also this diagram shows where the challenges are carried out. We haven't shown all the exact locations of these because they're to some extent decided on the day, but some of the distances won't change. They're specified in the rules. In other words, the distances travelled or the distances available for certain things. Okay, just a little bit about the structure of the event. So this is sort of as you go through things. So first of all, registration. Well, probably all the teams who are participating have registered. We are past the deadline for registration, or I think Fiona will let you know if I'm wrong, but I think it is still potentially open to new teams. We have a maximum number of 14 teams participating. So if we've reached that, then we won't be able to select add any more, but otherwise we will. Just be aware that you do have to also submit some documents. There's some documents, this is all specified in the rules. There are some documents that need to be submitted within 1 month of entry being confirmed. One of those is the selection of the optional challenges. We really need you to do that, please, as soon as possible, earlier than that deadline if possible, so we can select the ones that are running. And the other thing that you need to do within 1 month of your entry is to prepare an outline project plan. This is all shown in a table in the rules. And then there are other documents that need to be submitted. Arrival, more details of the course about this later. It's not until June next year, but we unloading and loading your locos are probably one of the most dangerous aspects of the contain the most risk of all of the things that we do on site at the day. So we need a method statement for that. So you'll need to prepare that. Then on the day or the 3 days of the event, we have scrutineering that takes place. A schedule will be prepared by our controller, Bridget, and she'll circulate that. You'll get that. But scrutineering will take place during the first couple of days of the challenge. All of these scrutineering checks are listed on the will be listed in the documents that are on the website. The purpose of these is to check for safety and for fairness. So you can't run a loco. The scrutineers feel it's unsafe, and we have to try and make sure everything's on a level playing field in terms of the competition. Then in terms of operation, there will be a timetable. You will be issued with this. The controller managing that is Bridget Eickhoff, and also the Friends of Stapleford Miniature Railway. They operate the signalling system and so on. But your link will be with Bridget, with our controller. Judging then takes place during the event, and there are awards for each challenge, plus an overall winner, plus potentially some other awards and certificates. The head judge is Bill Reeve, and the deputy head judge is Malcolm Dobell. Malcolm's on the call today. Then there are social activities which take place in the evenings generally, and more information about those nearer the time, of course. Okay, just coming to an end from me. So resources, I think the best location really is to go to the IMechE website. The link is there, and at the bottom, I'm sure you've already found it. That's where you can register. That lists all of the events, including this event. The next one is there's a networking day on the 7th of February. Where all teams are very welcome to come to the site and have a look around, walk around the track, see what if you haven't been before, that's really important to do. And we get talks from all the different groups who are running the event, the scrutineers, the operations people, and the judges. There are rules on the tech spec. They've been published for a while. I'm sure you've seen those. There are maps and drawings. There's news. There's pictures from previous events. That's quite useful. Also important, there are question and answer pages. If you want clarification on anything, then you can submit a question, and that question will be answered by the judges or by the organising committee, and the answer will be circulated to everybody. They're already up there, at least maybe not the most recent ones, but questions and answers are on that page, which you'll find on the website. Videos and briefings, radios from briefing sessions and so on are there. Right, just finally from me, Martin, I think I'm on time, but I just very quickly flick through the winners to give you a feel for what has been going on in previous years. So in 2012, we started. The first winners were Interfleet Technology. There's their nice small locomotive, worked very well. Second winners in 2013, the University of Huddersfield, very large loco, petrol engine driven. Well, I won't go through all of them. 2014, Transport for London won, and they won again in 2015. 2016, SNC Lavalin Rail won, and they won again, setting a theme for winning twice. In 2017, sorry, that's not a picture of their loco, but there we are. You can see the happy team. 2018, Ricardo Rail won. 2019, our first international winners, Fachhochschule Aachen, a very nice loco, swept the board and won that one. 2021, University of Huddersfield won for the second time, possibly the last time we've had a winner with a petrol engine driven locomotive. 2022, Fachhochschule Aachen won for the second time. And 2023, earlier this year, Poznan University of Technology won with our second international team. So Who'll win in 2024? Let's see. We're all excited to see that. Right, that's all from me, Martin. So if I stop sharing.
Thank you very much. Now, one thing to mention, well, so yes, I think next we're going to have Stuart with traction systems. I believe you decided to swap with Felix, so you could set yourself up. But just in the meantime, I should have mentioned there will be questions and answers at the end, and there is a question and answer box that you can write your questions in, and we'll keep track of those as the presentations are going through, and we'll answer them at the end. So thank you very much. Are you good to go, Stuart?
Yeah. Can you see my screen all right?
Yeah, that's all working fine.
Brilliant.
Thank you.
Okay. Hi everyone. So yeah, my name's Stuart Hilmundson from the University of Birmingham. So I've been part of the IMechE challenge since it's began and a mentor for the university's team. So I'm going to spend 15 minutes talking about the making the locomotive and train move and working out or giving you some tips about the traction requirements for moving the train. So it's all about how much power do we need, or how little power do we need, which is probably more accurate. In the world of railway power engineering, railway vehicles are always designed to meet a certain duty cycle, so a certain acceleration requirement, a top speed, and to be able to go up gradients, and those factors and solving Newton's law equations of motions and so on is all you need to do to work out how much power is required. And most rail vehicles in the real world aren't particularly over engineered, so there's no point putting more traction power in than is necessary, because you'll never get a chance to use it. That's completely different from the electric vehicle market, where you've got stupid amounts of power. No offense if anyone's got an electric car, but they're normally over-engineered, completely over-engineered. In railways, we don't do that. So it's important to do physics analysis on the locomotive to work things out. So this is a picture of one of the University of Birmingham's trains from a number of years ago, pulling two wagons there, two coaches. Well, the first thing I'd say is you don't need a massive force to push those two vehicles. So if they were on flat track, you'd be able to easily move them by hand. And in fact, in my lectures, when I'm teaching students in railway engineering at the University of Birmingham, one of the things I often ask groups of students, particularly from the industry, is has anyone ever pushed a real train? And most of the time, if there are people from rail industry in the audience, someone will put their hand up saying, yeah, I've pushed a real train carriage. So you can have a 40-ton train carriage in a depot or something, and people might need to move it by 20 centimeters to join up with another vehicle, for example, and often it's just done by hand, basically. So you can move huge loads on railways with not huge forces. So that's something to bear in mind, is you probably need less power than you think. So the physics of traction, things you need to think about really is basically solving free body diagram, the equations of motion for a train. So the train or the locomotive is going to produce a traction force, and then there's a resistance, which is basically the trailing load, and whether you're going up a hill and so on. So we then have F equals ma, which is mass times acceleration, equals the balance in forces, so traction minus resistance to motion, minus the slope. And actually the resistance to motion is pretty low. The thing that dominates the challenge really is the slope, and there is a slope, and I think there's information about how steep the slope is, but that will be the thing that decides kind of how much power you need to put in the train, and also how heavy your locomotive is going to be. So it's important to realize your locomotive has to have a certain mass to provide sufficient traction. So it's important to make a locomotive of the right weight. If you go too light, what you'd have is a locomotive which might have enough power in it to theoretically achieve the thing, but if the rails are a bit slippy, there's just not enough downward force to provide the traction required. So working out the mass of the train is important too, and you might well have to add mass to a locomotive if you make it very, very light. So the things that you need to work out, the required installed power. This is things like what is the mass of the vehicle, so that includes the locomotive mass plus the trailing load. What is the required acceleration of the consist? Importantly, what is the maximum slope? So that's going to be from experience, where the locomotives are all putting out their maximum power is when they're traveling up the slope back towards the station area. So that's the most difficult part of the journey. So that will kind of be the most significant factor when you're working out power that's required. Then adhesion, that's important because the adhesion is the amount of, or so basically the ratio between your normal force and the maximum shear force that you can achieve between wheel and rail. And that will obviously that shear force dependent on the normal force and adhesion. So you need to do the calculation to make sure your locomotive is heavy enough. And then also the power. How fast do you want to go up the hill? So that dictates the power that's required. So use Newton's laws and so on, work out some spreadsheets and so on to work out the fundamental power that's required to do the duty cycle. And as I said, the slope is going to be the most significant thing. Once you've got that fundamental power, there's also going to be some losses in the system. So you know the energy that goes into the traction system, so the energy that flows in will have losses associated with it as well. So you get some losses in the traction motors, losses in motion, potential energy losses, and some of it's getting turned into kinetic energy, which then you get back through regenerative braking energy. So once you've designed your traction system, you need to add a bit onto the top of it to make sure that you can cope with all the losses in the system. Now some equations that you're going to need to use. They're fairly easy to figure out. So the F equals ma. So m is the effective mass of the train. So your train has got rotating parts on it. So the wheels, any gearboxes and motors all spin around. And same for the trailing load. There's a certain amount of rotation there. So the vehicle actually has an effective mass which is bigger than the actual mass of the vehicle. So it may be like 5 or 10% bigger. So you need to use that mass in your calculations to work out the required force. Going up the hill, you use force due to gravity, then is mg sine alpha. As I said, someone might be able to put in the gradient. I can't quite remember what it is, but it's pretty small, and sine alpha for small angles is the same as alpha, so you don't need to worry about the sine bit, but that will give you the force required to go up the hill. And as I remember rightly, it's kind of in the low kilowatts that are required to pull the train, fully loaded 2 carriages up the hill. So it's 2 or 3 kilowatts, if I remember rightly, but that sort of order. And the power then is basically the force times velocity. So once you work out what the force is on the slope of your train and how fast you're going up it, then that works out the power that's required. If you want to get more complicated, you can use the full kind of Davis equation, and that might be important for those of you certainly who are doing aerodynamic calculations. The CFD stuff, you might be able to work out what your actual aerodynamic characteristics of your train are. Now some pictures. That's some pictures of trains. This is an Amtrak train. this is a locomotive haul train, so then locomotive with trailing vehicle. So that's effectively what you're designing. We're not doing something like this, which is an EMU, Japanese class 500 Shinkansen, very nice, attractive train. So it's nice to make trains that look attractive. This is one we've got in the UK. Perhaps not so attractive. A lot of people don't like these, but and they're probably not very good, to be honest, but there's some nice thinking behind these designs. These are pacer type vehicles. They don't have bogies, or they just have a single wheel set at the front and the rear of the vehicle. So the thinking behind here was to go for, like, you know, a lighter weight design, you know, maybe that'll get revisited in the future, and we'll have trains like that. But most trains tend to have bogies on them, and in the challenge you'll see certainly the University of Birmingham have entered trains with two axles on them, and the trains that do well on the ride comfort all have bogies. So bogies have a geometric filtering effect, and, you know, effectively 2 stages of suspension, so they're much better for ride comfort and ride quality, and also stability on the track, because the wheel sets are closer together. We have some better looking trains in the UK. Picture of Hitachi, so class, I think it's class 800 or 395 train, and this is an Avanti train when it was a Virgin train a few years ago, showing that. And then another picture of our train here. So just quickly then, so there's in terms of the motors that you can buy for running your train, there's kind of three key options. You can get induction motors. So most modern trains will have induction motors on them. So these are you know, serious bits of kit. Induction motors don't have any electrical contacts between the rotor, the bit that spins round, and the outside world. So they are really incredibly reliable. You know, you put a motor on a train these days, and generally you don't have to do anything to it for about 12 years, and it can, you know, run every day in quite an aggressive environment. And then after 12 years you come along and have a look at it and maybe change some bearings or something, and then send it back. So you know, I think the reliability of modern induction motors is phenomenal. A less common motor now is DC brushed. So we still have DC brushed motors in the real railway. They're rapidly becoming obsolete. Well, when I say rapidly, there's probably good like 10 or 15 years of where we'll see DC brush motors still in operation. So that's a thing. And then DC brushless are effectively AC motors as well, but put with permanent magnets in them. So this is something that you might consider. So low things like drones, remote control cars, lower power stuff. Well, but with enough power for the IMechE Railway Challenge, these can be used in your systems, and you can potentially run them off quite low voltage DC systems. So I think DC brushless. Well, all of them have been used in the challenge, to be fair. So you need to think about which one you might use. They've all got pros and cons, and all of them can, if you do them correctly, they can all lead to a successful locomotive. So a typical motor.
Hi.
Oh,
Hi. Sorry to interrupt.
yeah.
I don't know if it's just me, but I can't see your screen share. I can't see
Oh,
your presentation. I don't know why. I've
no.
rejoined and quite a few times, but it's not working.
Oh dear. Can anyone else see it? If I just done it without any.
I can confirm that I can see it.
Can anyone else from
have a few hands up from other people? Can people see it? Or?
Yes, I can see.
Okay. Yeah, we can see it. Yeah. Can anyone not see it if they shout out?
Right, yeah, so I
Apart
think
from
it's just me
yourself.
then.
Oh dear.
Yeah, let me try leaving and rejoining again.
Okay, yeah.
Yeah.
I don't want to fiddle with anything my end, because it might make it
Yeah.
worse for everyone else. So yeah.
Okay.
I'm sorry about that. Hopefully you can fix it. Right. Anyway, this is a picture of a traction motor with all the bits in it. One of the things, just well, I'm showing you this, is you need to effectively mechanically connect the rotor to the wheel set, and that drive system is quite complicated and difficult to manage, because the wheel set is obviously running along the tracks, and the motor's likely to be suspended somewhere. So you need a drive system which can have flexibility in it, like some sort of cardan shaft or universal drive system to run that. The other thing that's important is the motor RPM, revs per minute, is going to be very, very high, much higher, maybe 50 times higher than what the wheel set goes. So you need some sort of reduction gearbox, and that can be quite a challenge to get that right. So the gearbox and drive system is difficult to get right. You know, the lots of teams in the past have tried it with chain drives and so on, which can work, but they look like they're really simple, but they're actually very difficult to get right. So a lot of attention, I think, needs to be done on the actual mechanical drive system. There's loads of the stuff on the web about this. I'm sure you can find out yourself. I'm gonna leave that there for you. So next stage is to do some simulation work, working out all of your duty cycle, energy consumption, work vehicle speed, power demand, and so on. All of this needs to be done before you start selecting the motors. But then once you've done that, you can start thinking about buying a motor, whether you go for AC or DC. You also need a motor controller, and then something to control the motor controller. So the motor controller gives the power to the motor, but that motor controller would need an input to say, tell it what to do. So you need to design that as well, or buy that. The sort of common problems that we see is really electrical problems, which is things like mixing power circuits with electronics. So if you've got sensitive electronics and then some heavy cables carrying motor power, that you need to think about segregating them, because you can get induced voltages and so on, all sorts of things that can affect your electronics. So people have blown up motor controllers and electronics and so on, even blown up the motor. And you need to have an e-stop on your train as well. That's an important feature, but you really need to think about what happens to stuff when you do an e-stop. So you hit the e-stop, there's still energy in the system. How does it get dissipated? You know, if you've got capacitors in the system, you might need to have things like resistors that can discharge capacitors in the event of an e-stop and so on. Just a few things, and Felix is going to carry on this, is things to worry about. You know, it's an IMechE challenge, but quite often most of the problems are electronic, electrical, or systems. Where we need well, a couple of points to think about. One is you've got to try and do as much as you can before you do any building. Ideally, you want to design the system in a concept, do concept design, then go to a detailed design in CAD in a virtual environment, and then produce a bill of materials, then drawings, and then just have a build phase where you just assemble everything that you've already done in CAD. Don't try and build stuff and then design it at the same time. Things that are really important are cable IDs. So in your cables and electronic power cables, whatever, they all need IDs at both ends to make sure they work. Crimping and connecting to stuff with terminals, this is really important. Anything that's got screw in it is a terrible idea. So screw down terminal things are notoriously bad for coming wrist loose. Cable schedules, fuses. Also thinking about earthing, you know, what happens if something goes wrong? That's something that you think about it. These are obvious things, like you've got to do proper project management, got to do all the paperwork and get your vehicle tested ASAP. So things like getting your boss or managers and so on to come and have a look at your locomotive well before you're taking it to the railway challenge is a good idea, because you'll want it, and then read the manuals from the IMechE. That's my last slide. I'll hand over to Felix now. So we want to see locomotives where they look more like on the right hand side rather than the left hand side, when because if you've got a problem on your locomotive looks on the like it does on the left, you've got a real headache to try and figure out what's going on. So thank you very much. I'm going to stop sharing now and hand over to Felix.
Good morning, everybody. I'll just try to share my presentation as one does. Okay, so my name is Felix Schmid. I've been involved in the Railway Challenge as long as the other outdated people. So that's since the beginning. I think I slipped on 1 year, but I'm generally the troubleshooter to whom people turn when something doesn't work. And as Stuart has pointed out, the things which generally don't work are the easy things, which you have forgotten about because they appear to be easy. And also, I have to sort of criticize Simon slightly because he says you learn a lot about the soft things like project management, like time management. And actually, these are the hard things in the project because it's always, oh, well, it will work in the end. But really, you do need to have a very good plan. And so I'm going to say a few things about systems thinking and then a bit about pitfalls, which Stuart has already started to mention. So let's see what we can see. So Selelec has got what I consider to be one of the best systems engineering lifecycle V models. And
Hi,
one of,
Felix.
sorry?
We can see your presentation, but not the full screen version. Are you definitely sharing the right screen, or?
Oh, well, okay. I'll try and see whether that's the wrong screen. Yes.
Whilst you're sorting that, Felix, perhaps we'll ask Malcolm to start on his presentation.
Yeah, that seems very sensible.
Okay.
I'm sorry to mess things up.
Let's see.
No problem. No problem.
Let's see if I can share over the top of Felix.
Thank you, Malcolm. Yes, we can see a
That's
picture
working,
of
is it?
Sheffield locomotive. Yeah.
Okay. Yes. So my presentation is peppered with photographs from past competitions, and I'm going to talk briefly about the things we do in judging, which will a little bit cross what others have said, but from the point of view of the judging. So hopefully this will work. Yep. So prior to the weekend, there's all sorts of paperwork things to do. As others have said, it's a complex design, and the idea of the design challenge is that you write down in words and diagrams and tables what the design is, so that a generalist rolling stock engineer like me can understand what you're proposing and then mark what you've done. There's a thing that's required called a compliance matrix, which there's a sample on the IMechE website, which is useful for me to identify how you've complied with the various parts of the technical specification. And it's useful for you to make sure that you have complied with the technical specification and have written about it. Another thing to say, don't include diagrams without explanations, and don't include explanations without diagrams. Diagrams are really useful to make your explanations clearer. The final point on this is there's requirements to include written submissions about the optional challenges, and please make those as separate documents. The CAD challenge is a new one this year, and this is only for teams that are doing the entry-level challenge. And the idea is that you will give us a write-up of what you've learned from doing your design in CAD. Clearly, you will be using CAD software, but you must bear in mind that the judges don't have access to any CAD software and are hastened to add no CAD skills either. We're interested in your report. Innovation, Simon's already described that. You have to describe an innovative part of your locomotive design. It's in a learned paper format, and the judges will mark your paper, and during the weekend, someone like me will visit you and ask for a demonstration of your innovation. And you'll see from the rules that if your innovation isn't present or is not working, there might be a reduction in the points you've scored for this. The top 3 papers will pitch their innovations during the weekend in a sort of live Dragon's Den. The technical poster is simply that. This is an example, and if you look closely, you'll see it has a howler on it. But we'll also judge the appearance of your locomotive, and that will be a very subjective thing. But the idea is that the locomotives look attractive in some way, shape, or form. The posters are useful for judging. They're also very useful for the spectators who want to understand more about the design of the locomotives. Business case, we do the heats online. To say that the confidence of the presenters and the story they tell as is important as the veracity of the content. It's always useful to have a couple of presenters, to avoid just one, but don't try and have each member of your team say something. That just gets confusing for you, and it gets confusing for us as well as judges. And finally, the top 3 will do a live Dragon's Den event, probably on the Saturday afternoon of the challenge. The optional challenges, I'll remind you to submit your preferences. What we'll have this year is there will be a judge assigned to judge each challenge, and that judge will mark the written documentation and will also do the assessment on the day for all those challenges that require detailed assessment. The drag challenge, Simon said, is only paperwork, but there is a requirement for the judge to just check that the locomotive looks something like the model that you've evaluated. Next one is the method statement. So before you turn up, you're expected to deliver a video showing a locomotive performing on a test track somewhere that's not Stapleford, so that you've got some idea that it's performing reliably, and to deliver a certificate from a chartered engineer that demonstrates that actually this test has gone ahead and somehow the video hasn't been faked. You're also required to do various risk assessments and method statements for use during the event, particularly for the auto-coupler challenge, maintainability, and unloading and loading. But penalty points will be deducted if these are not available. So coming on to the challenge weekend, now others have said that actually getting a locomotive working is a big challenge in its own right. Reliability is key. There's a lot of pressure during the weekends to get all the locomotives to get their slots, and our controller is often having to juggle which locos go when. So reliability is probably the single most important feature of the whole design, and it's a success if you get your loco running around the track. So if you've not had time to fit auto stop or energy recovery, which are seen as 2 of the more difficult challenges, or you've fitted them but they don't work, then don't worry. It's still worth participating. It's still worth getting the loco to Stapleford and running and doing the traction challenge, the maintainability challenge, and the ride challenge. The reliability challenge actually gives you points which are getting deducted if the loco fails. And they're on a scale that are included in the rules. Maintainability is all about making sure that it's done safely, and the challenge is stopped and started at each stage to make sure that it's in a safe condition to work on before the next stage of the challenge goes ahead. And you'll see there the judges scrutineering very carefully to make sure that everything is both carried out in accordance with the rules and is safe. Auto stop is not just a challenge for the railway challenge, it's a challenge on real railways that use automatic train operation. And they don't always find it easy to stop trains accurately at stations. Too much braking, obviously, you'll stop short. Too little braking might overrun. And a little too much braking often causes an overrun. I'll leave you to think about that and ask me questions if you don't understand what I'm saying. But that is a significant challenge, and not too many teams have actually achieved good results in that so far. Ride comfort, just don't forget to provide a mounting plate for our accelerometer. One or two teams have made actually quite difficult to get at. It needs to be easy to get at. Energy recovery, the important thing here is you have to be able to demonstrate to the judge that will ride on your train that the energy recovered during that brake application, and only that energy, is used in the subsequent movement. And it's got to be convincing. There have been people who have measured voltage on large supercapacitors and found that the amount of the amount by which the voltage increases during their braking operation is tiny, and so the riding judge has been unable to verify that only that amount of energy has been used. So think about that very carefully, look very carefully at the rules, and make sure you comply. Traction challenge is carried out from a standing stop on the 1 in 80 gradient, which is the number that Stuart was trying to remember. The idea is that you go from a standing start, you don't roll backwards, and you set off, remembering to apply to operate the horn, and then you have to run over 12 meters and 10 meters. The 10-meter distance is measured and timed, and the person with the shortest time is the one that wins. And penalties, things do go wrong. Often it's forgetting to sound the horn before you move the train, or failing to, the examples here are failing to secure battery connectors. But also we can at discretion award bonus points for perhaps helping out another team. We will try and advise teams of the penalties they've received before prize giving, but often time is short, and we might only do that advice if the final 2 or 3 are very close, and it's the penalties that make the difference. So that's my lot. Thank you very much, and we'll see questions later. I'll stop sharing.
Thank you very much, Malcolm. So Felix, you've sent me your presentation. If you want, I can share it and you can carry on. Is Felix still on? Let me just check. Okay,
We've lost him.
It would appear we've lost Felix. In that case, maybe we move to the break a little bit early. So have we missed anyone? We've had Simon, we've had Felix. We've had Stuart. Felix was going to do Ivan's as well. Okay, I suggest that we move to the break early. So we're just going to have a quick break now, and we'll come back at 11:20, if that's all right, everyone. Just to remind people, there is a question and answer section. So far, we've had no questions, so it's going to be a quite boring question and answer session at the end. Please submit your questions anytime you like. Thank you very much, and see you in 10 minutes. Okay, it looks like we're still missing Felix. So, Michael, are are you perhaps available to start your presentation a little early?
Yes, of course. We'll try.
Fantastic. Thank you very much. Thank you, Michael. We can see, well, we can see your university logo. Thank you.
Okay. So can we start?
Yeah, absolutely. Go ahead when you're ready.
Okay, so good morning, everyone. We want to present you our team perspective. With me is Bartek Minkiewicz. He is in our team since 1 year. So he will help me because my English is not so perfect. Some data about PuTrain. We are the students from Poznań University of Technology. We are the part of Science Association, and in 2018 we want to try make something connecting with railway and build our own locomotive. In 2018 we developed our team and visit Stapleford to look how it's happened, how it's looks like, and we talked with other teams how to start, talked about the parts which other team use, and get some information about that. And in 2019 we come to Stapleford with our first loco. And we want to develop our vehicle and raise better prizes. But then in 2020 came a pandemic, so we can take only an online version of Railway Challenge. But in 2022 we visit Stapleford with our second loco, and now we developed this loco we built in 2022, and in this year our team win the competition. We take first place in reliability and refueling challenge. So we are proud of our loco, and I'm proud of my team. That the whole team spent lots of hours in our workshop. Sometimes when students come to our university to start the next day lecture, some of us come back to home because we work for whole night, and it's really beautiful that we can make it, and we can done it in this year.
Our teams is divided into 5 sections: mechanics, electronics, automation specialists, logistics, and marketers. And as you can see on the screen, but obviously this section do not work just on their own, because today it's quite impossible to make a functioning mechanical thing like a loco without help of electronics and automatics, because it's always connected, and our sections work together all the time. And also the marketers part is very important as well, as we'll tell about it in a few minutes, because it's impossible to create a local without funds, and marketing make it possible to get those funds. Oh, sorry, we get the far. The timeline of project the local always starts with planning, because I'm sorry, there is something probably a little bit wrong. Okay, so the project always starts with planning, because at first you need to evaluate your resources. You need to make sure that you really are able to do this. You are really able to build the local, because first off you need people, and you need people who are gonna be interested and who are gonna give their heart to the project. Because without it, it's impossible. Second thing about planning is that it can save also a lot of money, a lot of funds, and a lot of your time, because when you plan everything at first, you are able to estimate the time you need for task, and you are able to split the task between the team, so everyone will have work to do. No one will be bored in your workshop, and also there's not going to be a situation when one person needs to do the work for free. You also need to collect as many information about construction of the locals, about your possible problems as soon as possible, and second, prepare the documentation for the locomotive, because that's not only like the requirement for the railway challenge, but that's as well very helpful to know what you're doing, to have some previous drawings on the things you want to do, and that prevents from some mistakes, that prevents from any unwanted situations in the workshop. And another thing, it's also normal that during the process of the construction there are also some changes, and you need to document that changes. You need to get that into the documentation, so your locomotives don't become some kind of labyrinth you won't find yourself in. As I previously said about marketing, and again, there's some problem, really sorry. The marketing is very important, because you can have the idea, you can have the people, you can have the will, your heart to do the local, but without funds, without money, it's impossible. Because creating a local can be a little bit pricey, and so you need to create your promotional strategy and search for partners in the industry, probably as many partners as possible, but you also need to make sure that those partners are really interested in your project and are really going to help you in the way they can. After you have the project, after you have the people, after you have the partners to sponsor your project, it's time for the workshop activities. And first off, safety first. Like you want to build the local, you don't want to lose your hands. And so make sure that that everyone in the workshop know how to use all the tools, that everyone is dressed properly. That is also very important, and that it's quite good to have some person who's gonna be like the safety angel and gonna make sure that everyone is doing everything as safe as possible. And another thing is that tools are very important, but not only proper tools for the task, but also that you have good quality tools. Because of course you can get the tools from some kind of supermarket, and they will work as well, but proper good quality tools make you work faster and prevent accidents because they won't break or damage so easily. And also during the challenge, you want to have good quality tools. You want to be sure that if you need to like repair some basic thing, you will be able to do that and your tool won't break. And if you have the delays in the workshop, that is absolutely normal, because you always get some delays. You always, even if you had very good planning, like the best possible planning in the world, there is always some things you won't be able to plan. There is always some little mistakes in measuring, or there is always some problems with, I don't know, you bought some prefabricated elements and something is wrong with it. It's normal, and so it's gonna happen that you are going to have some delays, but don't worry, you will sometimes during the nights, but everything will come to be okay.
Yeah, and so when you've got your loco, you need to test it, because when you test your loco on your university, on your own track, you can get to the Railway Challenge competition and be sure that all components are good, have good connection with another, and all the and you are ready for the full challenge, because of course you can make small changes during the competition, but it's not good when you build your loco on the track. We know something about that because in the past we make a lot of work on the track to start in the competition, but it generates a lot of stress, and competition is beautiful time to have fun, to of course compete it with other teams, but it's not time to build the loco. It's time to make a small changes, but remember, changes in software during the competition, it's not the good idea, because something can small change can
Small change in the software can simply destroy like the whole steering software. And also another thing about software, always make sure that you have some backup of your software and don't make change of on the live software. It's never gonna end good. And also another thing about testing is that, of course, everyone testing just wants their locomotive to run. and it's absolutely understandable. We've got the same problem. But don't forget about mechanical parts, especially parts like springs or any other things which are connected with your not only safety but also the comfort of the locker, because it's happened that the springs, for example, can be too hard, and it also could be a very important problem.
Okay, so it's our advices. We hope that we can see you on the track in Stapleford in 2024. And we hope that a lot of team will join to our Railway Challenge family, and we can meet together in February. So thank you.
Thank you very much for that. I'm pretty sure when it comes to Sheffield's presentation, they're going to agree with you on the aspects of not changing software right before you're going out on competition. So, right, we have now got Felix back. So hopefully we can hear you, Felix.
Hello, yes.
Fantastic. And I'll just share my screen and you'll just have to tell me when you want to change slides changing.
It was the worst computer crash I've ever had in my life, I think. Teams was still running. I could not switch off Teams. So I apologize on behalf of my computer. So yes, change slides, please. I was starting to talk about the Senelec system life cycle, and what we have just heard from Poznan is very much evidenced really for this good thinking. And so I think the first point which people often forget is that the concept doesn't come out of nowhere. It has to actually be thought about. And the best way of thinking about the concept is thinking about what's actually needs to happen at the end. And that then allows you to define the system and the application conditions. And so an example of the application conditions is the track quality, which is not always perfect at Stapleford and not always perfect at other miniature railways which you might be using for testing. In particular, SNC can be a big problem. So when you think about your design, you really need to make sure that you understand the conditions. That gives you the system requirements, which must match those from the specification given to you by the IMechE. And then you can apportion those to different parts of the system and also apportion people to different parts of the system, because not everybody can do everything, as Poznan has pointed out very nicely. You then do the design and the implementation, and really this is the understanding the problem part. It's very, very important that you do that clearly. Then the next step, and new slide please, is the manufacture. And when you have done the manufacturing, you will need to put everything together. It is sensible to test things before when you have got elements of the system, not to try and test it all together. And one thing which is, I think, very important is that every time you do a step, you check that you've actually carried it out before you go to the next step. So that's what I call verification and what Senelec calls verification. Validation is slightly different. Validation is about checking that what you have designed is actually in line with what you wanted rather than just what you designed. So it goes much further. And one of the important points is when you are in the design phase, so on the left-hand side of the V, you really need to have a plan how you're going to do it on the right-hand side. So each of these horizontal arrows basically is a piece of paper or a piece of computer record to tell you what you're doing at that particular point, so that you can say, yes, we can tick it off. properly. And you then come into the operation and maintenance phase, and operation really is incredibly important, even though it's only a day or a couple of days at Stapleford. And I think, again, Poznan made a very good point about making sure that you don't change anything important. You don't try to build the locomotive. We had several years where people came along with 3 very large boxes full of bits and the chassis, and even the bogies weren't attached. Surprisingly, in most cases, they actually did the run of the circuit, but they couldn't take part in the competition. Decommissioning and disposal, well, how do we get into that? Well, you don't actually decommission. In most cases, the system is passed on to another group, and they will then have to work with what you've got. And that says documentation, 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 good drawings, and good drawings. So if you get those things right, then you stand a chance of actually passing on what you have done. Next slide, please. So this is an example of the Birmingham locomotive, and the person in the picture is Ivan Krastev. Ivan was supposed to be here to talk about what he did in terms of innovation and what the challenges were. You can see a red cylinder at the top, and this was the first ever hydrogen locomotive on any part of a UK network, admittedly a narrow gauge network. And Ivan had designed and built probably the first power drive system using silicon devices. So it was a unique system. It was highly efficient. It worked after a while, but it was a very, very big challenge because there was so much innovation in this locomotive. So be very careful about innovation, but do innovation because Malcolm likes it when you actually submit an innovative design. And this was very innovative, but if you look at it a bit more carefully, you see lots and lots of loose wires, and I can't see any labels on them, so you don't really know what each wire does. Everything was in Ivan's head, and had he not been there all the time, the locomotive would not have worked. Surprisingly, it worked in 2024 in a new guise, but unfortunately, somebody made a wiring mistake at the last moment and the locomotive blew up, as has been mentioned. You do need a spare electronic drive, and because otherwise you'll be stuck without any power on the system. Next slide, please. Drawings are very important. This was a train which derailed at the points, so that's a good example of ensuring that you know what your system has to cope with. Next one, please. And here is re-railing the locomotive. What you also see is that it's a chain drive, and as Stuart has mentioned, chain drives have got a lot of fans, but they are very, very difficult to align. They are very difficult to control, and you have to have a very strong bogie or body if you want to use chain drives, which are absolutely aligned. Next slide, please. This is on the left-hand side a very nice picture of well-arranged battery connectors. Battery connectors are very, very important because there's a lot of energy stored in a battery and they need to be absolutely safe. And in this case here, you can see something which looks really rather attractive with proper connectors and easily disconnected, in this case for the refueling challenge. But again, this is one of the locomotives which emerged fairly late in the day, and it did run around the track, but it was not a great success because the planning and the management had been really not very good. Next slide. This was the last year's, or the 2022 University of Sheffield locomotive. Fairly well organized in terms of the power wiring, and Stuart mentioned the power wiring as a very important issue, because if you don't have that, then you can get short circuits which tend to be fatal. And also you can see a fairly decently arranged air system. Next slide. I don't think I need to say very much about this, but surprisingly, the locomotive worked, but you do need to have very good wiring diagrams. The wiring diagrams need to be in line with the schematics. The wiring diagrams need to be in line with what you've actually built, because otherwise you're going to struggle to do any troubleshooting. And if I'm taken to a locomotive like this, I will always start with looking very carefully at where there might be a wire touching something, because that's usually the problem. Next slide. Fairly neatly organized. There's clear divisions between the different parts. So left batteries, middle power system, right control system, and you don't see very many flying wires. Things are properly tightened, etc. And I think that was a point which somebody else made. Screwed connections are not necessarily ideal, but if you use proper kit, then you can make screw connections fairly decent. Next. The same system from the other side. It looks perfectly decent. Nicely connected power systems and nicely stacked electronics. Next slide. I think that was it. So I'm very happy to answer questions, but just to go back to it, the diagrams need to be up to date, and they need to link seamlessly from the schematic diagram, which has got black boxes on it and connections between them, to the wiring diagram, and then to the actual build of the locomotive. And any time you spend on the left-hand side of the V is time well spent. So thank you very much, and I'm happy to answer questions later on.
Fantastic. Thank you very much, Felix. An interesting insight into many of the locomotives there, actually. I've not necessarily seen those pictures before. So, right, James, are you ready to go?
Yes, I think so.
Fantastic. Well, just before you take it away, if you do have any questions, I've seen a couple come in, questions and answers. Well, feel free to add more. Simon's responded to them in the question and answer section, but we'll perhaps go over those verbally as well. I can also open your mics up when we get to the question and answer section, and we can ask questions verbally if anything comes up whilst we're in that. So, yeah. Otherwise, James, take it away. Thank you.
Can everyone see the screen?
Yeah, that's great. Thank you.
Cool. Yeah, as I said, I'm James. I'm Railway Challenges at Sheffield's technical coordinator this year, and I'm a first year PhD student. I've been a member of ARCAS all through my undergrad degree, so for 4 years now. So yeah, as Martin mentioned right at the start, he founded Railway Challenge all the way back in 2013. So this is our 10th year anniversary. So we thought we'd cover a bit about what we've done for the last 10 years and what we've learned along the way. Going to quickly cover who ARCAS are and then run through generally how our year runs around a university academic year, go over the last 10 years of ARCAS, and then finish off with some advice for teams that we've learned along the way. Yeah, ARCAS, we are the University of Sheffield's entry into the IMechE Railway Challenge competition. We're a student-led co-curricular activity, so that means that we're not run by academics, it's all run by students, and as a co-curricular activity, we're outside of the degree, so we don't do it for credit, we do it for fun and learn a lot along the way. Funding, we're primarily funded by the Department of Mechanical Engineering, and we get a lot of additional funding through sponsors. So main sponsors Firm Frame, we get lots for other different bits of the locomotive. So as I mentioned, the team is primarily composed of undergraduate students. We recruit from all across the Faculty of Engineering here. Our academic and PhD supervisors are drawn from the Department of Mechanical Engineering. So I'm not going to delve into these too deeply, but we recruit from all across the years, as I said. We recruit from all across the years. And we have a current team size of 29 people. And as you can see in the left-hand pie chart, we have 10 team members currently out on a year in industry placements, which is great for them, but it did mean that we lost a lot of experienced people this year, which is why I'm still on the team. So RCAS as an organisation, we're split into 4 teams. The first team is the management team. This tends to be the more experienced students. They do the organisation, the coordination of the team. We have our structure and dynamics team. They're responsible for the chassis and the bogie and also the suspension. Our mechanical systems team are primarily responsible for our powertrain, and the electronics and control systems team, they're responsible for keeping the magic smoke in the wires. Don't really understand what they do. I'm a mechanical engineering, but yeah, they do all our control system. So the management team is quite large for RCAS. This is because as a co-curricular activity, we do all of it in our spare time. So we need lots of people to make sure we cover all the things that need to be done for the competition. So we have our technical coordinators, the sub-team leads, and also additional team coordinators to help with recruitment and marketing and socials. We have our 2 PhD supervisors from the mechanical engineering department and our 2 academic supervisors. So they help us with additional advice and also sign off our health and safety. So as a co-curricular activity, this brings some advantages for us, but also has some disadvantages. So I'll quickly cover those. So advantages, we're very independent in our decision making and in our organisation. So we get to choose like the direction of our design and also like have to learn from our own mistakes as well. So as a co-curricular activity, the team members can remain on the team for the duration of their degree. So it gives us a lot of time for getting into the project over a number of years. We get a lot of passion for the project, a lot of commitment and a lot of learning out of it as well. It also means we've got good continuity and knowledge transfer throughout the team. So the younger students can learn from the older students, and yeah. And as you go through the team, you get a lot of opportunities for doing a wide range of different roles. You get a lot of different experience, and it's very beneficial for people going out into industry. Yeah, and a strong social group within the team as well. And yeah. So the disadvantage of RCAS being co-curricular is that it's not for credit. So it means we don't get dedicated time within our degree. So it means it's all in our own time outside of our core degree time, so evenings and weekends. This means that when academic works get busy, so exams and coursework deadlines, it means that time for RCAS gets compressed. And as I mentioned before, it means we need a large management team and a large team generally just to make sure we get all the work done and the workload's balanced out across people. So an RCAS year, we start off in September, we set our targets for the year and we start our recruitment process. And October to December, which we're just getting to the end of now, is our core design period. So that's when we do most of our design work. Then in February, so after January exams, we do our final design modifications and start ordering all the parts that we know are finished. March is our main procurement period, and then April is our manufacturing period. So we traditionally have a manufacturing week in the Easter holidays. And then in May, so when everyone's busy with uni and coursework, we try and find a day to go testing or a couple of days to go testing, and it means that that's when the electronics team can do all their tuning of the locomotive. And then after our June exams, so a couple of weeks before competition, we have our final testing period, and then obviously competition itself. This is a visual representation of the year. I'm not going to delve too deeply into this because I've covered it all, but the key key thing here is that actually in the year we have quite a lot of time away from RCAS for university exams and holidays and things like that. So recruitment-wise, well, as a co-curricular activity and student activity, recruitment is very important. We need to replace a lot of the outgoing team members. So as I said, we do that in September. We do that typically through our social media channels and also through the engineering fairs at the university. Applicants go through a 3-stage recruitment process of like an essay, a group task, and then a one-to-one interview. So yeah, as I said, across the Faculty of Engineering and any year group. And this year we had 12 new recruits from 36 applicants that got through to the second stage, I think. And then once they're on the team, we do CAD training, skills training, and also introduce them to the locomotive. The RCAS design, we do that primarily through 2-hour meetings on a Tuesday evening. We also then encourage sub-team meetings to help them with additional problem solving. And a core part of our design work is we have 2 design reviews, one in the autumn semester and one in the spring semester. And this is a great opportunity for us to get like focusing on where our design's got to and also get feedback from alumni and sponsors and other experienced engineers as to where we might be making silly mistakes. And we do a lot of them. So manufacturing wise, yeah, 3rd week of Easter break is traditionally our manufacturing week. Procurement concentrated in March, and our aim for our manufacturing week is that we have a structurally and mechanically complete locomotive by the end. Last year, the electronics team and the structures team had a brilliant idea of introducing a modular electronics shelf, which allowed the electronics team to build the control system separate to the locomotive and then drop it in at the end of manufacturing week. And it meant that we were very ready to go testing pretty much, I think, a week after manufacturing week, which is much sooner than normal. And it led to us getting a loco to competition that worked straight away, which was great. So yeah, testing wise, we have 2 test tracks, like 2 testing methods. We have a temporary test track outside the back of our lab that we set up on the road. It's very short, but it allows us to test our basic functionality, so speed control, e-stops, lights, horn, everything that we need to make it go. And then to do the proper testing of like the challenges and continuous running, we normally use Queen's Park Miniature Railway in Chesterfield, but that's washed away, so we're going to have to find a new one. Yeah. So obviously, the best bit of the RCAS Railway Challenge competition is the competition itself. So this is just a selection of photos from RCAS's time. And as you can see, in many previous years, we've had late night working, so much so that several times in the last few years, our electronics team have seen the sunrise. And then, as I mentioned before, RCAS as a team has grown. We've got a good social thing going on where we like doing different kinds of socials. So we've got our formal dinners. So we have one at the end of the year and one at Christmas. We have our fancy dress socials, and often they involve alumni coming back. So it's a nice way to keep in contact with RCAS past and present. And then we have our sober socials, so bowling and trampolining and things like that. So yeah, RCAS has been around for 10 years. So we've gone through a lot of different locomotives. The early RCAS locomotives in 2013-14 didn't have a loco. It was the first time the team came into being. So we've gone through a lot of different changes. I'll go into these a bit more in a minute. And then this is our kind of post-COVID recent years. The team has grown and we've gone back to a single body locomotive from our very successful snake train. These are a few quotes from our alumni and team members about what RCAS has given them in their careers. The key thing with this is that RCAS enabled them to find out what they enjoy in engineering outside of their degrees and gave them a lot of soft skills and also the technical skills that maybe the degree didn't have time to give them in terms of like practical engineering and things like that. And yeah, a lot of the feedback was that RCAS led me into the rail industry. I'm still in the rail industry, and in some cases, I'm still involved in the Railway Challenge competition. This is a snapshot of the teams that, the companies that people from the RCAS team have gone into. So a very wide range of different roles, a lot of rail, a lot of energy. So over the last 10 years, RCAS has had a lot of learning experiences where things maybe haven't gone quite to plan. So starting in 2015, the team broke the code the night before competition, trying to make a few last-minute modifications, and had to spend a late night fixing it. And then got to competition. It worked surprisingly well, so I'm told, until it derailed because the suspension wasn't calculated correctly. In 2018, there were several gauging issues with parts not being CADed correctly into the design and then having to be modified later on. And also, we forgot an exhaust pipe for our generator and melted the bodywork during competition, and it fell off. And then, yeah, the next year we had to make some last-minute powertrain skirts where our external powertrain skirts weren't up to the task, and that involved some chicken wire. A lot of the learning experiences involve design errors where we've not put things into design properly. So in 2021, we spent a lot of time drilling out the laser cut parts that we'd ordered because we decided to account for the width of the laser when we ordered them. We didn't need to do that. And we also had some more ordering errors when we had ordered the wrong length of aluminium extrusion. And the big problem we had in 2021 was that because of COVID, electronics parts were in short supply and we didn't give ourselves enough time to get them, which meant we only had one spare control board when we went to competition, and then we fried it, so we had no control system. So we had to rip it all out at competition. In 2022, the key feedback we got was that we tried to make something we knew didn't work, and it didn't go very well. And we learned a lot from it at competition, but it meant the competition itself wasn't very successful. And that leads us to this last year just gone. We swapped back to a single body locomotive and it was remarkably successful, but we did have a few errors again. We had to chop 20 millimeters out of the middle of our locomotive about a week before manufacturing week started because we realized we were out of gauge. We ordered a wrong part, so we had an indoor auto stop beacon that doesn't like sunshine, which led to us overshooting auto stop at competition. And we also didn't really consider how to waterproof our locomotive properly, which meant we had to use a lot of duct tape at competition. But we have had some successes over the last 10 years. So in 2014, the team was created. We came to competition with a lot of tools and set the culture for RCAS of helping other teams at competition by bringing all of our toolboxes with us. In 2015, we turned up with our locomotive, which was very rudimentary, but functional, until it fell off the track. In 2017, the team entered every challenge for the first time, and we also won the maintainability challenge. In 2018, we transitioned to our snake train locomotive, which was formed the basis of the loco for the last 5 or 6 years. Very successful design. And in 2019, we won the reliability challenge with the snake train proved to be quite a robust design. So bits could go wrong, but it would keep going, which made it quite useful for a student team like ourselves. And then also in 2019, was the first time we got all of our past team leads back together. So that's a notable success. And then after COVID, we had a very successful locomotive. We finished second despite needing to repair our control system, and we won a surprise for our aesthetics as well. And then last year, as I said, we returned to a single body locomotive, designing and building from scratch in a year. We learned a lot from 2020 and 2021 with our control system not going very well. So we swapped to a modular control system, which meant if something goes wrong, we could just remove it and it would just keep working. And the additional testing time meant we posted a best ever RCAS score. It was just unfortunate for us we did that in the year that everyone else was very successful as well. The strongest railway competition yet. So that leads me on to advice for like other teams from what we've learned. So one of the main pieces of advice that was given by alumni was that keep it simple. A locomotive that does the basics is a very good way to go for competition. That's what we did in 2019 with our go-kart train. It started and stopped and we finished second. Something that we've realized this year that's very important is you need to pick a starting point. So either choose your powertrain to decide your bogies around, or design your chassis around your power control system. Make sure it all fits together, but pick a point to start from. As I mentioned earlier, design reviews, we find them very useful for getting feedback from more experienced engineers, and also it's a good way of us checking that we're on track with our design work. Another important thing is following good CAD practices during the design process. That add all your fastenings into CAD. It makes it really easy when you come to order that you make sure you're getting all the right parts. And it also, if you think about how you're going to have to build stuff that you're designing, it makes the assembly process much easier. Another key thing that come out is have fun, be sociable, talk to other teams of competition, have fun in your own team during the process. It makes it all a lot more enjoyable. And also on the socials that we have, we often come up with some interesting design solutions that we wouldn't have thought about in a more formal setting. As I think Felix and Poznan mentioned, paperwork is very important. It's important to include it in your planning to make sure you give yourself time to do it. Start it early and make sure you have time to go through several drafts. And they are easy points to be won at competition. It's silly if you don't do the paperwork because you lose a lot of points, and it has been a difference between winning and losing and places at competition in the past. And as we learned last year, testing early is very important. It allowed us to get to competition with a working loco last year. So you need to order parts early, test your subsystems before you assemble the locomotive, and always take all your tools and equipment to testing and competition, because otherwise you will leave the one part you need behind and have to drive for half an hour to go and get it. And a nice quote that we got in the feedback was, fail hard and learn harder. Try. You won't always be successful, but we've learned a lot over the last 10 years. And yeah, a lot of good engineers, hopefully, have come out of our castle. Thanks. Yeah.
Fantastic. Thank you, James. I think I can imagine where that fail hard and learn harder quote came from. I can think of who that might be. You also mentioned the software and the importance of testing. Yeah, all things that I think most of the presentations have hopefully hammered home today. So unless I'm mistaken, I believe we're moving on to the questions and answers stage. So 2 questions have come in on the chat, which various judges have answered. Simon, are you best placed to perhaps go through? So let's start with the one we had first. What is the exact definition of a wheel set for the Maintainability Challenge? So they're asking, since their locomotives has no mechanical through axles and can only remove individual wheels.
Yep, shall I comment then? I did put an answer in the... It's a
Yep,
question that's cropped up before in different ways over the years, and there are various answers given if people look back through the Q&A sessions from previous years, which are all available there. But I think the nearest one was just a team asking for the definition of a wheel set, and in their case it wasn't because they had independent wheels, it was because they wanted to know exactly how much of the traction system. Remember, it has to be a powered wheel set. So they were asking how much of the traction system has to be removed. So the answer that I gave was the answer we gave to that, which is that it has to be the wheels and the axle. If obviously in this case there isn't an axle, well, fair enough. But the related braking and traction equipment and the axle boxes. So I think without knowing the detailed design of this setup, presumably we're going to ask them to remove both wheels, because that would be the fair equivalent to a wheel set. No axle, fine, but then there must be a traction system delivering the power to the wheels, so that the part of that that's linked to the wheels will have to come off, and any braking system or anything else which is attached to the wheels. It's kind of the unsprung mass. I put that in the answer there. That's perhaps, don't know if that's useful or not, but the part the mast that's below any suspension system. So normally the axle, above the axle boxes are the springs. That's my answer anyway. Are they asking us supplementary? The wheels are directly connected to our motor. Well, if they're really directly connected, then the motor will have to come off as well.
I guess that's equivalent to a well, locomotives I'm more familiar with a chain drive. The wheel set would come off with the sprocket because the sprocket is attached to the wheel set and unsprung. If your motor is unsprung, I guess the same applies.
Yep, unless they want to disconnect the wheel from the motor, there may be a possible mechanism. I can see Felix has got his hand up as well.
Yes, there was a comment about braking equipment. If you have some of the braking equipment fixed in the bogie and you take out a wheel set with a brake disc on it, then you wouldn't need to take out the actual brake
the caliper
actuator. That would be fine. But where you have a motor directly attached to the wheel, then I think you definitely have to take that out. So the key point will be a very good arrangement for the power to the wheel, to the wheel drive, and that's actually not a very easy thing to get right, and it has to be easily disconnected without falling off on the vibration. So it needs to be a very good connector, probably with a threaded part, so that it's safe in position.
So we have just had further clarification / question. If we unscrew the wheels from the motors, would that be sufficient?
Well, it very much depends, I think,
Simon,
Martin,
whether this might be getting to the point where you need to answer.
I think we need a drawing, because if the motor is effectively the axle box, then no, it'll have to come off as well. I think, that wouldn't. You couldn't just take a wheel off. It's almost like taking it off from the end of the axle. I know there isn't an axle, but if there was an axle there, we wouldn't let somebody just take the wheel off from the end of the axle. So if the motor in some way is performing the job of the axle or the axle box, then probably it'll have to come off as well. I think we need a drawing.
There's some real life.
Sorry, Malcolm.
Design. Yeah, there's some real life designs of rail vehicles where the wheel is effectively the rotor of the motor. And there's some of those tram cars use that sort of design. I'm also aware of some trains that they're not necessarily in service yet, where the motor and the axle are not removable separately, again in real life. So as Simon says, I think we need to see what you're proposing, and then we can come forward with a suitable response.
Can I just check which team this is? Maybe I should be able to see, but I can't.
Can I also comment? My recommendation would be to, regardless of what the rules are, to keep the motor with the wheel, because that's the critical connection, and the other connections are probably slightly less so. But you have to make sure that when you refit the wheel and its motor, that it's actually in exactly the correct position. So it's not enough to just screw it in, because there you have got the tolerance of the screw fit, which can be a millimeter or more. So really, you need to have something which gets it back exactly in the right position. Otherwise, you're likely to have a derailment.
Martin frozen. He has. Can people still hear me?
Yeah. I can still hear you,
okay.
Simon.
Yeah, we'll just have a quick look at the other question that was there then, which was about a trailing load. Let me just find it. Yeah, for testing at other locations, is it required to show it can pull other carriages or just the locomotives? Is okay? I'm not sure I fully understand the question. Maybe we need clarification, but in principle, for all the on-track challenges, the loco travels around with a trailing load. In previous years, it was one carriage. I think, Malcolm might correct me, I think we're going to have two carriages being pulled by the loco this year. Sorry, you're muted, Malcolm.
I'll get used to this one day. We've had two carriages for the last couple of years, but what we've seen in the videos is that if they're going to run at any reasonable speed in their testing, they have to have a vehicle on the back in order to carry the driver. We have occasionally had people provide a video showing the 20 minutes of reliable operation with it running up and down a 5-meter long track, which it possibly meets the letter but not the spirit of what the requirement is.
So basically, yes, need to be pulling a trailing load, and I think I had a quick look, and it specifies that it's a maximum of 1,200 kilograms for the trailing load. That's specified in the technical specification, so it's up to that.
And as we know from 1 or 2 experiences, despite all the calculations people do that Stuart took us through, the very best winning locos have been able to haul a very long train full of passengers. With great credit to the designers of those locos. You're on mute, Felix. Felix, you're on mute.
Having a locomotive run even 5 meters backwards and forwards is better than no running. And so if you have got problems, then I'm sure we would accept a film which shows you running up and down enough times. If you have a bit of a curve in it, that makes it more realistic. But there are constraints in many locations as to what you can actually do.
Yeah, that's absolutely right, Felix. And indeed, we've had locomotives that have had a thorough test on a really extensive miniature railway that have had serious reliability problems when they've arrived at Stapleford.
There's also a very interesting experience of the Newcastle team last year. They were running late, and the only access they had to a test track was a different track gauge. And they actually built a locomotive which could be re-gauged basically on the day. And that was a very, very good solution to their problem. And they had done proper testing. They had some other issues, but I think they were very remarkable. And both the members got jobs in the industry as a result.
Okay, we seem to have lost Martin, but I don't see any other questions now. Does anybody have any other questions?
Yes, I've internet on my computer,
Right.
but I've rejoined on the phone, so I'm somewhat limited in what I can do. But I do just want to say I have launched, just before I lost connection, hopefully you saw that I launched a poll. That poll is anonymous, so if anyone wouldn't mind, if all participants would mind filling in that poll, just to give us an idea how useful they found this session and in what format we could perhaps run it going forwards. My plan now, given there's no more written questions, was to open the floor up with mics. I'm not to the participants. I don't know if I can do that on my phone. So perhaps Simon, you might have to take over there. If anyone has further questions, feel free to put your hand up, and then perhaps Simon can let you speak.
Oh, somebody's just telling us there are more questions in the Q&A session, but I can't see them. Malcolm, can you see more questions in the Q&A session?
Well, I can see them.
Yes.
Why can't I? Can you read them out then, Fiona, please?
Just trying to, which ones have been done?
Close and open again.
Okay, I'll start from the top. So one from Finn. To clarify on test track gauge, we are struggling to find an open 10 1-inch gauge track here in Scotland. Does the experience of Newcastle mean we can use a wrong gauge track for testing?
Okay.
I think we'd already had
Have we
that
done that one?
I think we'd had that conversation with the Heriot Watt team previously, and we said yes, but you've got to demonstrate that the wheel sets are securely mounted to the axle, and it's got to be. And if you use a test track which is a wider gauge than at Stapleford, then you've got to be able to demonstrate that the stability on the narrower gauge is okay. If you're testing on a narrower gauge railway, well, it is less of an issue for us, but clearly it's still an issue for you. In effect, the Newcastle experience is a good precedent that you may employ, but it's still got to be safe.
Okay, I hope that answers your question, Finn. Next question from Dan. Will the waterproofing be tested this year?
Yes, it will.
I don't see why not.
Scrutineering
why is he asking the
does
question?
that.
Sorry?
I just wonder why the question's risen. We haven't changed anything related to waterproofing, have we, Malcolm?
It's part of the scrutineering.
So yes, it will definitely be tested.
And can I make a comment about the waterproofing? Birmingham last year, in 2023, taped up the ventilation slots, and that led to the meltdown of the electronic equipment because they suddenly realized that their locomotive was not watertight. So that's a very important question and a very important point.
The eagle-eyed among you might have noticed pictures of the Sheffield locomotive with red tape around all the edges. That's presumably waterproofing as well.
Yeah. And on the question of adjustable axles, wherever you do something which is not locked in place by design, you should not use just screws to hold it in position correctly, but shims or discs in order to keep the thing at the right spacing, because other things tend to loosen, particularly on the bad track we have got.
Okay.
Martin, do you want to continue doing the questions, or would you like me to?
I can do. I don't know. Just let me know if you've already answered some, because I may have missed a bit. So we've got one from James Hardy. Just to clarify, on auto stop, we have to remove all traction power at the 25-meter mark. So presumably that's 25 meters before the stop point. Is that?
Not sure if I completely understand, but basically for the auto stop, the locomotive has to detect the marker, and at that point it has to take action to stop the locomotive by the 25 meters later when there's another marker.
So it doesn't sound like there's necessarily a requirement that all traction power is stopped at that point.
I don't think we ask for the traction, anything related to traction power or braking, really. It's just what they have to do that. The loco has to do that itself.
Okay.
It can still be applying traction, I think, can't it, Malcolm? Right up to the
absolutely. It because 25 meters from the speed they're doing is plenty of distance to stop at a very low brake rate, so they can keep going with traction power, apply a higher brake rate later on in the stop, and still stop accurately if that's what they want to do. They've got to work it out for themselves.
Fantastic. I have just opened up my participants' microphones, so if there are any clarifications they want, they can speak to you. Right, so James Higginbottom, as I mentioned in the presentation, we currently don't have a long test site, so I think this is a question to anyone, not just the judges. Can anyone recommend a local location for sufficient testing? So James is from the Sheffield team, so ideally something geographically accessible from Sheffield.
We did find that there was a website which listed all the 10 1/4 inch gauge railways, or maybe the public railways, and there are quite a lot. I'm sure we could find that again and circulate it around.
I'll find it and post it in the chat.
Okay, thanks, Fiona. Of course, that doesn't mean they can necessarily run there, but at least they could ask.
I could have sworn I've seen them at a test track at Chesterfield.
Yes, so that's I think it's called Queen's Park, but unfortunately, I understand
closed,
it flooded recently, so hence James's washed away comment during the presentation. I guess they might be back up and running, but James will presumably know more. Right. Okay. So we've got one from Ed Atkinson.
And Michael's got his hand up, I noticed. Martin, sorry, go.
Yes. Well, I'll go through the
Yep.
written ones first,
Yep,
if that's
okay.
okay. Does the data recording need to be done at the remote location, or can it be done on the locomotive separately from the remote monitoring? So this is about the optional challenge with remote data location, and where does the data need to be recorded?
Can you answer that, Malcolm? I'm just quickly looking for the thing. I don't think we've specified that it can't be recorded on the loco.
It can be recorded on the loco,
So
but
it can be recorded, yeah.
but the remote data monitoring is to record and display the data in the marquee near the station.
So I guess where that question comes from is perhaps if you were to record the data on the loco, but it was only accessible to view, but from the remote location, but not actually stored in the remote location, would that be okay? Or do you need the data to be stored in the remote location?
Well, I have to say that if the data is transmitted to the remote location, the storing it becomes trivial. And I say that even as a sort of 72-year-old who's come to computers quite late.
As a 71-year-old, the biggest problem at Stapleford is mobile phone communication. Yeah. And if you really want to transmit data live, then you almost have to set up a system of your own. Otherwise, it's going to be really problematic. What might be better is you collect the data on the locomotive, and at the Wi-Fi point or Bluetooth point, you download it. I think that's the safest situation. Or even
I'm not sure that's what the rules actually say.
No, that won't do.
And I have to say the bandwidth that's required for the data isn't all that big. It's not as though we're trying to transmit photographs or even worse, video. But we do accept that the 4G coverage at Stapleford is not good.
I mean, if you what you might want to do is when you are at Stapleford in February, actually carry out some experiments with your own kit. That would probably be the best way of trying it.
Yes, I guess it's conceivable. I'm thinking aloud now, Felix. That
so do I.
we could use a mobile radio link for data, like the campus radio we use for communication amongst the judges and the officials.
Yeah,
we have talked about having something. Can I just share for a minute, Martin, and I'll just found the actual. So I think it's this one. Are you seeing my? So this is the remote data monitoring. So it does say that the monitoring device should be operating and confirmed as displaying live data from the locomotive. So it has to be live, really. So we couldn't do they couldn't run and then download. It doesn't say where it should be stored. It says it should be stored, but I guess, as Malcolm points out, if you've managed to transmit it to the marquee, you might as well store it in the marquee, or both. I don't know. Okay. I think teams just need to read this carefully, and if something is not clear, then send in a question.
Okay, great. So I'm just going to skip over the auto coupler because there's a couple of those. I'll come back to those. We have another one on the optional. Well, this is on the location announcements challenge. Can we use track-based assets to trigger the announcements for the location announcement challenge?
Does that mean they want to put a marker down on the track?
Yes, and I guess in a similar way to teams do for the auto stop challenge, putting something physically down on the infrastructure.
I believe we've had that conversation, and I believe we've said that they absolutely, Simon, that there's no reason why they shouldn't do that. They can do that.
They can do that, but I don't think we intend that this has to be an automatic thing. The driver can press a button Isn't that right?
No,
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 maybe I'm wrong
no,
on
no,
that.
no.
Okay,
I don't think so.
No.
That would be
Okay,
too easy.
so then they'll
Simon.
have to put something down.
I was going to say that does sound pretty easy. Right, okay, so we've got two related ones, both about the auto coupler. So one from Ben Souters, that's in the rules and technical spec, we're unsure of the carriage side interface they're working with for the auto coupler. Is there a more defined interface they can work from? So I guess that's drawings of the actual point the auto coupler must connect to on the carriage, and then yeah, perhaps cover that one first, and I'll come back to the second one.
Yeah, we have had that question, haven't we? I think maybe we need to provide a bit more information. There is in the tech spec section 6.2, it describes the coupler. I can put it on the screen if you want to, but it sort of describes it, and it says how high it is above the rail level. But maybe that's not quite enough, I think, is what we're thinking, that we do need to provide a drawing of that. Have you had that discussion, Malcolm or Felix?
No, I haven't, but I agree with you.
Yeah, okay, so I think we will provide a drawing.
So Ben, perhaps the best way for that to happen is if you can officially submit a question to the IMechE, then that can be responded to. But it sounds like there is agreement.
Is that okay? Does that answer Ben's question?
Okay.
Yes, I think that makes us happy. Thanks.
Okay, great.
And related to that, are the couplings between the loco and any wagons required to be metal bar? Oh, so I don't think this is related to the auto coupling challenge. I think this is just about the standard coupling. Is it required to be the metal bar that is defined in the specification and has a drawing on the team rules, or could they add dampening to their coupling? Is essentially the question.
Oh, I think, well, my immediate reaction is yes, they could add damping if they want to. Anybody disagree with that? Probably better have a formal question so that all teams can see the answer.
I'm struggling to envisage what it's for or how it helps. But
well,
there's
in
nothing in the
I
rules.
guess, is it to
There's
cushion
nothing in the
vehicle
rules that says not.
No.
Well, my only thought is that there is a drawing of a drawbar in the rules. Is it specified that they must use that drawing, or is that just an example for reference?
No, it says, in fact, it says here, I think I'm sharing my screen again, drawing RCO5 shows a typical design for a coupler bar. So I guess, you know, we've left it open a little bit.
Yep.
And there's the description that I was talking about.
I would think that half of the bar has to be present because that's the thing which interfaces with the carriages. So if from the halfway mark to the locomotive, you can probably put anything as long as the other end is at the right height and that's the right freedom of movement.
That sounds reasonable.
Here's a comment from someone saying during the noise challenge we had problems with the wagons banging against our locomotive.
That won't be a problem. Oh, okay. Won't be a problem anymore because we haven't got a noise challenge. But
and in reality, the noise challenge was dominated by wheel rail noise anyway.
Yeah.
Okay, great. So we had a hand up from Michael at Poznan. Are you still? You should be able to unmute, Michael. In fact, you were a presenter, so
he might have been answering a question rather than.
Oh, right. Okay.
Possibly, I don't know. Are you there, Michael? No, maybe gone.
Okay. If anyone else has any further questions, stick your hand up or just open your mic and let us know. Otherwise, I mean, I think the idea for the last bit of the session was we're perhaps going to make an attempt at networking. Well, if I can do this one of two ways, we can either do one big discussion in the main room, or I can put people into smaller rooms if needed. So I guess let me know what you're thinking on that. But just before we do that, James, you had a question?
There's been another question in the Q&A chat about ride-on locomotives.
Okay, have I
I
missed
still
that
can't
one?
see the Q&A. Can you read it out, please, Martin?
Ride-on locomotives. Could whoever asked the ride-on locomotives question, would you like to open up your mic and ask it verbally? Because I can't find that unless it was in the chat.
Oh, I've got it. Actually, I've got it now. Is it this one for the novelty that the train driver can sit in the locomotive? Does the train driver have to remain completely in the clearance gauge, or is the train driver allowed to extend upwards at the train? Yeah, okay. I think we've had this question sent to us. We haven't replied yet, although we've replied to a similar one from Harriet Watt. The answer is no. The driver does not have to remain within the loading gauge. That would be very difficult. But the answer that we've prepared, and which will be circulated soon, does point out that there are safety implications. The tunnel portal, for example, is, I think, just over 1.6 meters above the rail level. So the teams will need to demonstrate that that safety is being considered, that the driver, if they extend outside the loading gauge, which they will do, will be safe. And I think what we're specifying is that a 95th percentile male seated in the arrangement that the team has provided for them will not, the top of their head won't be any further than 1500 millimeters above rail level. That's basically, so the answer is no, they don't have to remain completely in the clearance gauge. We're going to provide a little bit more detail. Of course, this is only an optional one for this year, but we're proposing that it will become the norm for next year, 2025 onwards. Does that answer the question, Andreas?
Okay,
Sorry,
great.
can I ask another question on that point?
Yes, go ahead, Ben.
If we're explicitly allowing drivers to be outside the loading gauge, is there a reason to not extend the loading gauge upwards?
It's a good question. I think we wanted to have a loading gauge because, you know, that's part of the constraints of normal operating of a railway. So that's the way we've defined it. I suppose what you're saying is, can't the loading gauge extend as far as the tunnel portal? Any thoughts, Malcolm?
It was something we'd have to discuss with the railway. What we're doing is we are generally keeping within the envelope of the Stapleford rolling stock, recognising that people put into this environment are more flexible than locomotives. So if one needs to put a head down, you can, whereas it's a bit difficult to put a head down of the locomotive. That's a bit of a trite comment.
There did used to be funnels that got put down, didn't there, Malcolm?
Well, I think that was on the liners, wasn't it? on the
Also-
lake.
I think
No, also on
I would
trains.
have concerns increasing the height of the locomotive because
Yeah.
it's a very narrow track gauge and stability will be a problem, especially if somebody decides to put a couple of hydrogen cylinders or batteries right at the top of the structure.
Yep.
You would actually not be stable.
I think the answer is probably going to. Sorry, Malcolm.
I was going to say if that happened, we'd probably have to introduce a tilt test of some description or stability test.
I think the answer is we're not planning to increase the loading gauge. We're just allowing exceptionally a driver to extend outside the loading gauge. If you want to ask a question about that more formally, if you've got a reason why you want a higher loading to make your vehicle higher, then send a question. But I think the answer is going to be that the loading gauge is what it is, and we're going to define what how the driver can extend out of that.
Malcolm, a
sir.
sway test may actually be a sensible addition next year.
Yes, we'd have to think out how we would do it.
Yeah, we could
The
probably
same
arrange
way
it,
as you
couldn't
do
we?
it on the rail locomotives and rail trains.
Yeah.
Okay. Has that answered the question? Was it? Forgot who answered. Who asked?
Okay, I think. Oh, hang on, we might have a new one. So one from Dan Collier. Where can we find the clearance gauge?
It's one. It's a drawing. Drawing. Can't remember the one. It's on the website. RC02 maybe. From memory. Can I just check, Fiona? Was there anything you wanted to ask everybody? Are we, in terms of submitting?
Yeah, I might use this opportunity just to give everyone a reminder. So I've sent out your registration confirmation emails. There's a few deadlines included in that email, specifically to submit your optional challenges, and also to let me know if you haven't already, nominating 1 or 2 members of your team to be added to the machine platform so that you're all set up and ready to upload all your supporting documents for the challenge. I will be circulating out your team welcome packs over the next couple of weeks, but you should receive that shortly, so just keep an eye out. It'll just have all the information that you'll need, and as always, if you have any questions, just pop an email to myself if you have my direct email address, fiona.wong@imeche.org, or you can send it to railwaychallenge@imeche.org, and I will forward any technical questions to the judges and the volunteers. Thank you.
Thank you, Fiona.
Can I just share for a
hand up
second, Martin? Sorry.
Yeah, go for it.
Just to answer that last question. So this is the team document library, which you can easily find from the top level of the page, rules, tech spec. And if you look down the bottom, sorry, it's got a little bit hidden, but down here is the various drawings that we've got. And drawing RCO2 is the dynamic loading gauge. Sorry, it's on its side, but anyway, it's very simple.
Simon, whilst you're showing your screen,
Yeah.
Did you mention there was an area with videos? Is that worth pointing out?
Yeah, okay. So if I just go back, so we're on the top level. We're not on the top level, that's team resources. Okay, so team resources, event information, past events, photos and videos from previous. So it's here in past events.
Oh, okay.
Being a bit slow now, but there's various. No, sorry, that's just the results. Might need Fiona to help me.
There is an event gallery. Is that what you're trying to look for?
Yeah, if you try on event gallery.
Which one is it? Which?
Sorry, in where you had the results, there was a button to the event gallery at the top of it.
Right. Okay. So it is in past events. Sorry, I must have just missed it then.
Just at the top.
Oh, okay. Yeah. Yeah. Although I think that's just pictures, not video. I think that's pictures, not videos.
I'll pop a link to the YouTube challenge.
Okay,
not YouTube
thanks,
challenge, the YouTube channel with
Yeah.
the Railway Challenge playlist with all the past videos that have been uploaded. So I'll just
Great.
pop that in the chat.
Thanks. Is there not a link to it from one of these places?
I believe so. It might. You might have to dig around.
There's
a
so
bit,
much on here now. It's just
there's so
difficult
much
to find
information.
anything.
Yeah.
Okay. All right. I'll stop.
Okay, fantastic. Sorry, yeah. Just before I go to you, Finn, thank you very much for answering the poll. We've actually had 24 responses to the poll, so that's fantastic. We'll look at those results afterwards. But by the look of it, it's mostly positive, so that's great. Finn, you have a question. Do you want to open your mic?
Yeah, sorry.
Oh, you sound very strange, Finn.
Sorry, I'm quite mad at the minute.
Finn, we're struggling to hear you. Could you perhaps type your question? Your sound is very poor. Felix, you've got your hand up.
Yes, John Lee has offered to do a YouTube video about braking, I think, and I don't think it's been done yet, but we probably should talk to him because it is a useful bit of information. particularly the nature of what's failed to safety means, because none of the real railway safety braking systems are actually failed to safety. And but some people have done some not so clever things about that. I may record something about failed to safety electrical circuits, but I haven't got time at the moment.
Okay, perhaps that's something. Oh, here we go. We've got something from Finn. So that's actually to you, Fiona. Can you see that there?
Yeah. So we have our planning report due for Saturday, which be able to get access. That's fine. I will just add yourself in to the machine platform. If you want to nominate anyone else, just let me know. But for now, just so you can submit your planning report, I'll just add you onto the platform. I'll pop you an email.
Thank you very much. Yeah, so I don't think there's any more questions. Jamie, did your hand go up James, did your hand go up briefly? It seems to have gone down again, so I don't know whether that was a mistake. Otherwise, I think if people want to chat, feel free. Should I put people in smaller rooms, or do we just want to ask chat in a large room? Okay, well, no one's opening their mics in a large room, so I'll take that as if any networking is going to happen at all, I'll have to put you into smaller rooms. So perhaps if I just give me a moment, and feel free to, well, thank you very much for all of us if we don't speak to you again. But yeah, feel free to leave if you're in, if you've had enough, but otherwise I'm going to throw people into different rooms and you can start to have a chat.
Before everyone leaves, can I just say thank you to you, Martin, for arranging everything, and to Fiona for helping, and to all the other speakers. Thanks. I think it's been a really useful event.
Yeah, thank you all.
Thank you. Okay.